This is on page 512 in your book. So we have a baker that claims that the mean of the height of his loaves of bread is 15 centimeters on average. He has some loyal customers and they don't believe him. So to persuade his customers, he's going to do a hypothesis test. He bakes 10 loaves of bread and the mean height of the sample loaves is 17 centimeters. The baker knows from baking hundreds of loaves that he has a standard deviation of a population, and it is 0.5 centimeters, and it is distributed normally. The null hypothesis then can be set up that H0, right up here, H0, is going to be mu is less than or equal to 15. The reason I need to have it as less than or equal to 15 is because I want the alternate hypothesis to be that it is greater than 15, which is shown by that 17 centimeters. They want to prove that it is larger than 15 centimeters, the mean. So that's why we use the words is more than, right? Because of that. So since we do know our standard deviation, and it's a normal distribution, we are doing that sampling where we're going to find that sample error of the mean, which is going to be our standard deviation divided by the square root of our number in our sample. And we get this normal number here, which we can then calculate our p-value. So let's just look at this picture for a minute. We have this nice drawing. 15 is the mean. So we're going to see if we can disprove that 15 is the mean. Up here is 17. What we want to say is that the probability, this area under the curve, greater than 17, that is just as likely to happen. So if we prove that this p-value up here is in the normal range, then we can say that we need to look at this. If the p-value is very, very, very small, which it looks like it might be in this case, we can say that 15 is really not the mean. We would reject 15 as being the mean. Now we can do a couple other things here before we actually start calculating. When we talk about our standard deviation, which is 0.5, remember that almost all of our data is included within 3 standard deviations, which in this case 3 times 0.5 is just going to be 1.5. So it would come out to 16.5. It wouldn't even reach 17. And that should include all of our data. So right there we can tell that probability of it being in this tail is going to be very, very small. So a couple of ways to do this. We could just make sure our calculator is turned on, and let's see how well this films here. We can look at underneath our distribution here. We can go down to our normal CDF and enter that. And we want to start with our lowest number that we're talking about. Here we're talking about from 17 onward. So our lowest number is 17. We're going to put a comma in. And you can put 10 to a very large number. Sometimes I just stick in 1,000. 17 and larger. Okay, so 1,000 will work. And then we want to make sure that we put in our mean, which is our 15. And then we would put in our standard deviation if we weren't doing this sampling, which we are this time, so we're using this formula. So it would be 0.16. Close my parenthesis. And if all that went well, I get, if I'm going, here's my decimal point, and I'm going to move it 36 places this way. Okay, that is very small. In fact, that is what we call 0, right? It would not even be in the realm at all. So what we can say about that, let me just click on this and scroll it up a little bit, is that it is approximately 0. Our p-value is approximately 0. And that tells us it's highly unlikely that a loaf of bread is going to rise no more than 15 inches on average when we have one that was over 17. So 0% of all loaves of bread would be at least 17 centimeters high. Purely by chance had the population mean really been 15. But it is so unlikely. It's not happening by chance alone. We conclude that the evidence is strongly against the null hypothesis, and we can say that there is significant or sufficient evidence to reject that null hypothesis that the mean of the height of the bread is 15. Hopefully that helped a little bit. We're going to show in the next couple examples a more straightforward way to get to what we're talking about on the calculator without necessarily calculating that p-value separately. We will be doing z and t tests. So in the next example, I'll show some of that. Thank you.